Okay, how was the last lesson went for this week? It was.
I managed to watch it. I didn't.
It's the same here. I managed to watch it twice, but I think still require a lot of interpretation. This week was interesting though, but it was all code, so it's more to do with doing stuff rather than watching.
Anyone was able to do homework?
Yeah. Me not.
Silence.
So I've got a question. If for stuff like this, what would you recommend as a good source for someone who's relatively new to? I mean, there's a whole lot of object-oriented stuff here, which I think is a prerequisite to some of this. Is there a good resource that someone's been able to use to help them out? Because I think just jumping straight into this, I find quite tough. It would be actually nice to actually understand some of the basics before I go into here. So I'd appreciate any resource that anyone can recommend.
Well, it depends a lot on your prior knowledge, I guess. I mean, there's so much stuff for tutorials for Python. I don't really have anything in particular in mind. Depends a bit where you're starting from, I guess. Like, have you programmed in any other language?
Yeah, I coded in university about 15 years ago, so I can code if a gun's pointed to my head, but yeah, but not with not object-oriented and Python. So
okay, I mean the only thing that I don't really know. I mean I was doing Python for a long time, but the thing that's probably most confusing is the dunder init, the dunder methods, I guess, because they're kind of special class methods. And then that you need to handle the methods with self. Basically, the reference to the class is always self, and you always have to push that as the first argument. Yeah, I don't really know that there's like one really good source for that stuff. It really depends what you already know, I guess. But is there anything in particular that tripped you, or just in general need a bit more background?
Well, it's just that, I mean, I would have, I think I'd like to be in the position where I read this stuff and I'd know straight away what they're trying to do. So almost like, yeah, I think that was my hope. And that's what Jeremy sort of mentions many times, that, he writes stuff so that he can just look through a couple of lines and knows what it's doing. And yeah, so I guess that just takes a whole lot of work, but I was trying to fast track some of that, but I guess there's no.
Okay. I mean, if there's any particular points, I'm sure we can clear it up, but yeah.
Yeah, I think I'm going through a same process. I have been a programmer throughout my life, but initially I started 20 years back C, and then C++, and then left, and then I have been doing Oracle, and coming back to Python, it is quite different. Even I have been programming in like SQL and a PL SQL.
Okay.
But what I found is, what I try to do is I try to print as much as I can. Every step, rip it up. For example, if you see here, he has done in one line, which is for a beginner like myself.
But I mean, to be honest, that's not Python. That's Jeremy's Python. I mean, yeah. It's the only guy I know that's programming in this way, so it trips me up as well.
Yeah, so in a sense, even that doesn't even help. So what I try to do is, rather than have just in a one line, I'll create four for my readability, and then that's the only way I can learn, I guess.
Yeah, I mean, I get his point that it's good to learn the library if you see as much like or an entire function in your screen, but it's really hard to interpret if I don't know. It's good to get the overview, what's happening in a class or anything, but you can't really make the content pop.
So how would you write it, Christian, this line?
I would just break it. I mean, for instance, well,
would you do like 4 lines?
I would just have a more visual aid, basically. Okay, never write like an if statement in one line. this kind of stuff always, like after the if question line break and then the content of the if, or I always would have spaces after the comma. So you have a visual break, like with the tuples, that you have self x, comma, space, self y, comma. I don't know, it's maybe a habit. Maybe you can get into it. Probably if you're really focused, then he is right. Or like the line, create tree line, right? There's, no, hang on, sorry. And yeah, I don't know. And he's also like, on top of that, he's using these super short variable names, right?
Yeah.
I mean, I don't know. It's not, I mean, it's not super hard, but it's confusing if you've seen other code.
Can we make it full screen, maybe, if that's possible?
Yeah, sure. Let me.
Yeah, well, that's, you know, that I was trying to bring that up last week about he's creating his own language, you know, and using cryptic things like NP for,
I think it's present.
you know, and so forth.
To the right top.
But, was it this?
Yeah.
Or was it another lecture I saw where they were talking about the inline if statement and how that communicates better than, more quickly than the traditional if statement, like if this, blah, 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 instead of doing it in line. And there's JavaScript is beginning, you know, to take advantage of that to even pulling the word function out and using equal sign greater than.
Yeah, I mean, to me, to be honest, I mean, some people hate it, but for me, the great thing about Python is actually the visual indent, that you see like what's in the loop and everything. And in the if statement, he's kind of killing it with these one lines, right? That you get the structure of what's happening. A lot of people with the curly brackets hate it, but for someone who started with that, you see by the indent what's going on. But anyway, it's still proper and good code. It's just a bit getting used to, I guess. And I see his point that it's good to get an overview of a module or something, right? If you can see the entirety of it in one terminal window, then it's kind of good. But yeah, it need to focus a bit to see stuff. And I think he went from like the train variable from 3 digits to 4 now, or 4 to 5, or whatever that was, the variable name.
Well, you know, Christian, you're communicating is that, like me and a lot of people here, there's this thing called production, and someone down the road isn't going to know any of that, and they're going to see your code.
Yeah.
And this is, you know, a classic example of spaghetti code.
Well, it's not really spaghetti. The structure is there. It's just really, to me, a bit unnecessary, hard to read. It feels a bit like Fortran.
It's obtuse. Yeah.
He mentioned in the beginning that he doesn't follow the standard. I think.
Yeah. I mean, I guess he gets it on Twitter a lot.
Or warned.
Complaining, I guess, but
Yeah.
it's his kind of code base, so it's fair enough.
Yeah.
Yeah, so he uses the justification for the short abbreviations. There is a how to say it, there's a way of coding, and it's got a name. I need to find it how it's so basically the like the names that you're going to use very often, he's trying to make as short as possible, so you don't have to type like very long, which is maybe really good to understand, but it's going to take you a while. So for those things that he's going to using often, that's the rule, kind of, to keep it as short as possible.
I mean, to me, the short variable names are okay. It's more the kind of white space use, but
I see he's not consistent. Like sometimes he's leaving that space after comma, sometimes he's not. So I can see that's kind of like, yeah.
But I mean, to be honest, I was digging around a bit in the code base, and I like the general kind of structure and how they design stuff. It's actually pretty good. Like their class factories and this kind of stuff. It's actually pretty clever stuff. So it's, at least to me, I can learn quite a lot how they design the stuff, the API, and yeah.
One of the rules I always use was that when I write a program, I don't try to educate the writer on the application. I assume any other programmer understands the application, like say this was a inventory system. I would expect him to know how that works. However, the difference here is that it takes a long while to figure this stuff out. And when you get to that point, the way he's doing it, you're already familiar with the lexicon, you're familiar with the structure. So I don't think he's really doing that bad, because it's going to take quite a while for someone to understand the domain and the application.
Yeah. And I mean, what is really good about it is like the kind of building blocks there, they are kept really kind of small and concise. I mean, you know, that it breaks it apart into small classes or functions, and makes you hop around a bit in the code base, but it's pretty consistent in this way. Anyway.
So, I have a question. If any of us is working as a data scientist, how they're writing code in a production itself, when they do the data munging and then apply the model and everything, are they putting loads of comments, loads of formatting, following this Pepe 5 code base standard, so that the other data scientists can pick it up? Or is it like this, what we have here? It's just a working condition. What's the opinion, and how actually in a production people are doing it?
I mean, I'm more coming from numerical computing in science, and I mean, I think people try to follow software kind of standards, which is, okay, don't comment anything that's self-explanatory. So if you have a variable, don't repeat it in the comment. Be consistent, have a consistent naming scheme, and you also have to realize that this is basically a library. So normally it's like the inner workings don't really affect us. We have to use it, so the API needs to be consistent, but the inner workings, of course, if you want to understand it and everything, then it would be helpful if there would be more verbose. But for a library, I think it's fine. And actually, with the new docs page, I'm kind of fond of that. That's actually pretty good. That the way they auto-generate their docs, and I mean, I don't think it's weird code, and I don't really know anyone who's really following PEP 8 to the line, because it's like super restrictive. I guess people aim for it, but it is really hard, especially with line breaks and stuff.
So you're talking about the version 1 of the library, or you're talking about like the way it's built, or 0.7, or both?
I don't really know both of them in detail, so I'm just looking. I'm kind of looking at the 1.0, and whenever I peeked in there, it looked really good. But I don't really know that many big code bases, to be honest. I mean,
okay, yeah, so the question about how to learn Python is, so I think previous lesson, Jeremy started about the classes a little bit. He did like a mini lesson about how classes are built in Python. And also in a deep learning class that is now going live, there's a topic on the forum about Python learning resources. So maybe we could point to that in our Slack group. People put together a list of courses they've tried and they worked for them. But
yeah, it's probably good advice. Yeah. I mean, to me, what kind of is tricky about this question is that you can program in Python in a million ways. Like I'm kind of programming Python for 10 years now or something, and I would assume that in the first 3 or 4 years I never used a class. So like I did purely kind of batch programming functions going from top to bottom, right? And you don't have to use object-oriented stuff, but if you use frameworks or stuff from people that know what they're doing, it will be normally object-oriented, but you don't have to use it. So it's really hard because you can do it on so many different levels. You can do it like as basic kind of clone. You can do it as a C# kind of thing, Java thing. So it's a bit tricky. So you can level up quite a lot and changed his style. And with the decorators and all the new features coming in as well, the language itself is kind of changing as well. But have a look at this forum thread. I don't really know it, but I think that's the one thread in the version 1 where people are looking for advice. So that's probably good.
Okay, that's really helpful. And I think what you said is absolutely right. You see, I've been programming for a while, but I've never had to get into the object stuff. But because they're using classes and so on here, it just seems weird. So I think you've hit the nail on the head there. So thank you.
All right. So on this lesson, what I gathered, the first point, I think there was this question: how big is your validation should be? I have just started, so people usually say 70-30, but this was like when I was listening to the video, it's quite interesting. So what's the opinion or any experimental anybody has done, raising up or bringing down percentage of a validation to see the score changing? Any opinion on it? And interestingly, he mentioned this magic number 22. So where the t distribution would get equivalent to the normal distribution. So what I gathered from this point, he's saying that you have to have minimum of 22 cases in each type in validation test or a training data set. Am I interpreting it right?
That was his qualitative gut feel as to that works for him as a minimum number. Okay, a heuristic.
Can anyone kind of repeat how he derived it? Because he did, but I forgot like how he reasoned about it, why that was.
What he was saying is he mentioned that the t distribution, again, I'm not a statistician. He mentioned like the t at the number 22, t distribution will get equivalent to the normal distribution. So at one point he mentioned that, and then he said like they did a lot of experimentation, and they reached to this conclusion where less than 22 of each class is not present in your either of the data set, you won't get the result right. So that's why he mentioned like that's my magic number.
Was there a name for that or a term so one can Google it?
No, I think it was just the minimum number that you need in that t distribution to then it becomes very similar to a normal distribution.
Yeah.
And the idea being that you can do. I mean, there's so much work done on the normal distribution. So if you can get to that level, then basically you can take advantage of all of the work that's been done on the normal distribution, because you can approximate it. You can approximate your classes to that.
Mm-hmm.
So does it mean, let's say if you have a feature, 10 feature, you will be looking at unique value on those that has to be minimum 22? Is that what it means?
Yes, I'm not sure about this 22 as well. So if you do the random split, would you?
Someone asked if you didn't have 22, what do you do? And his response was augmentation, to just or annealing, just create a bunch of copies, different angles and so forth. So they come up to 22.
Yeah.
Modify the data.
That was actually kind of related to that. Does anyone know if version 1 has oversampling in there? I've never seen it, but this kind of idea that if you have classes that are underrepresented, that you oversample them, but it's not in the library, right? I haven't seen anything where it's done by default by the library still. I think you have to do it on your own.
Yeah, that was also my question, whether the library would take care of it or whether you have to do it yourself.
I haven't seen anything like that.
Yeah, that'll be interesting.
So I'm pretty sure there's one in scikit-learn. Can anyone remember what that? There is definitely one in scikit-learn, but I don't know what it is. But I'm not sure about the Fast.ai one.
I mean, in scikit-learn, you can specify weights, right? Or what, are you talking about a dedicated function?
I can't remember. I just know that to be able to do that, there is that function to be able to do that.
So I'm just assuming when you do in a scikit-learn, you import the train test. When you split into a train test sets, maybe that takes care of your sampling in it, recreate it and return back to you.
I don't think so. I think
No?
I think so. This is what I understood from what he was referring to. I think it's when you have so for example, in the when you have an application like fraud, where the instances of fraud is significantly less than anything else, so less than 1%, maybe even less than 0.25%, and then you upsample that in order for you to have a representative sample so that you can make some sense of it. That's how I understood it. So I don't think when you do a train test that actually helps deal with that.
So you need to call another function or something in a scikit-learn.
Yeah, so I think that's when you use that. There is that functionality available in scikit-learn which allows you to be able to boost. So in the fraud example, it'll be one which will boost the instances of fraud, so that you have a representative sample, and then you can then train your model based on that.
I just found the link for that the magic number is actually 30. So maybe everyone has their own magic numbers.
Yeah, that was the one I was using TWiML, like applied statistics kind of thing. That was the 30 always. And then the Minitab, that's another kind of statistical software. They kind of say 25. So I guess anything around like this kind of 30-ish number, it works.
Okay.
30 plus minus 8, I guess.
Well, back in the day, it was 32. That was
Right.
It keeps changing.
Yeah, keeps going down. It's a good sign.
Yeah, just
We'll be 21 next year.
I just shared a link in the comments or the chat. Of the illustration from A New Kind of Science, which is a book by Stephen Wolfram, which kind of illustrates if you have a random walk process, the distribution that can be inferred given different orders of magnitude of sample sizes. And to me, it's a helpful illustration that kind of demonstrates that, with just 10 random points, you don't necessarily are able to infer a normal distribution. But when you get to 20, it starts to look at least slightly normal.
Well, I'm looking at it. It's already a stretch with 20, right? That looks pretty sketchy.
You need 1 million to really infer it, but it just kind of illustrates that that it starts to take on more of a normal distribution as you get more.
Mm-hmm. I guess it's also based around confidence, how confident you want to be that you have that kind of distribution or that kind of average. So the more samples you have, of course, the more confidence you will have in your results, but it's always balanced. Mm-hmm.
So that's the code we have for the self-random random forest. Anybody wants to give it a go, or we just go to next slide or whatever? It doesn't make much sense. Half of it makes sense to me, but half I still need to go through it.
Can you point out? I mean, we can discuss it. If it's probably easier if you point out where you kind of.
Okay, so let's say this line number self tree. What's this object tree? Trees. How would I go and say what this object is?
That's the collection of trees that makes up the ensemble. That's like a list of trees. So basically, this brackets expression, that's a Python thing, and that's list comprehensions. So it basically means for E in the range of 0 to the n trees, do the first one, create me a tree, and they are stuck. I just need to go to the door, but that gives you a list of trees.
Right. So
that's initializing the list of trees that you want, because you have your input is n trees, and this is going to give you trees in the initializing instance.
So what would be the n trees then in this case? Are we sending the sample, like, let's say I have 1,000 rows, so I am sending like 1,000 rows in it?
Depends on what, yeah, it depends on what you want. I mean, if you want to do a bootstrap sample, then a full bootstrap sample means that if you have 1,000 samples, then you want oh, I'm sorry, this is the number of trees that you want. This is something that is a hyperparameter. I think you ask for how many trees you want, 10 or 20 or 40, or and you build a random forest of that many trees.
I think we used like 10, 30, and 100 or something like that.
Yeah.
Yeah, these are one of the parameters you have to enter for random forest.
You experiment with, I mean, in his notebooks before, he's experimented with 10, 20, 40, just to see where you stop gaining from increasing the number of trees or starting to overfit. So then you have to try different values, and then you back off to the one that doesn't, to the best one.
Okay, so in a sense, for number of trees, we are calling this method, which is called create tree, which is this method. Is that correct?
Yeah, that's right.
Okay, and then it's storing all the trees.
Yeah.
The number of trees which we are calling.
Yeah.
Now we're coming to this.
The next method has a return, right? The create tree one.
Yeah.
And that returns a decision tree, and all these decision trees end up in self.trees.
Okay. And so decision tree would be another method which we'll be writing afterwards.
It's another class. Yeah.
Okay. It's coming.
It's a tree class that's coming further down. I think the way he wrote it is basically that he sketched it out and then later on filled in the gaps, right? So he was kind of designing it top to bottom. So he didn't really write all the bits that he needs. He was just sketching it out, and later on he actually wrote it.
Yeah. Okay. And the last one is the predict, which will come in the end.
Mm-hmm.
Okay, that makes sense.
And the predict is just averaging over the decisions made by all the trees and adopting that as your.
Correct. Yeah. Okay, let me go to the next. So we continue on the code. So that's why I said I'm just gonna pull the whole code. I'm not sure. Is my screen okay?
It looks a bit wide.
Yeah. Well, like, this is me. Sorry. I kind of like stretch it up, just fill it. So that in the first slide, that was the decision tree. So here he's writing a class. Why class? Why not a method? What is?
Because it's kind of an object. Like one tree is an object in a forest, right? So the tree has properties, and you store lots of trees in a forest. That's a kind of a hierarchical object relation, if you will. You could write that perfectly fine with functions as well. It's just, it makes sense to encapsulate it like this.
So it's like an independent class we are writing here as a decision tree.
Yeah, if you go back, you see, I mean, he's basically just writing the tree ensemble as a container around all these trees. Okay, and they are all stored in this list, and the list belongs to the tree ensemble.
When you say tree ensemble, you mean this?
Yeah, a tree ensemble is a class, right?
Yeah.
And the class has a property, like a variable trees.
Yeah.
And that's basically a container for all these individual trees that are created with create tree.
Correct.
So it's like a bunch of trees that belong to this tree ensemble.
Yeah.
And they can then later on be all affected or used with mean, right? Where he's iterating over all these individual trees again.
Yeah. Oh, sorry.
I guess the difference is that with a function, you're generally interested in returning one number, but with a class, you have all these properties that you can access, not just one number. You can access, the number of trees. You can access the data that, the X data, the Y data. And
you can separate concerns. Like you can put like the properties of a tree where they belong to the tree, right? And like the overarching properties of your ensemble. could be with the ensemble, and they can talk to each other.
Okay.
You know what he means by ensemble, right? Just a group of things.
Yeah. Yeah. So, and what's the difference between this decision tree and this decision tree?
And a what?
I think the one further down is just more refined. There's more content. I think
he's defining it.
So it's one is the same thing. It's just more refined way of writing the same code like this.
I think he was just building it up.
He's extending it a little bit. Yeah, he's working on it. He starts out with the simplest, skeleton definition of the decision tree, and then he starts developing it.
Yeah. It's just drafting it at top and then actually fills in the bits that you require. You need a score, you need the validation, the value, sorry.
So can you have a class, here we define a class decision tree. Can you do like redefine it here?
He's just overwriting it.
Okay.
It's the same class.
And you can do it, like you can have a multiple time, you define once and then
Python doesn't care. Python, you can just overwrite stuff in because it's all dynamic.
Yeah, as soon as you execute that second cell, it just wipes out what was in the first cell.
The first one.
Yeah.
Okay. And one thing, what interesting part I found is the score is infinite. So
that's just the initial. That's just the initialized value. So you initialize the score as infinite.
So he's saying that the initial score of our tree is infinite.
Yeah, and that would help you to see if, for example, if you execute this thing and then the score comes up as infinite, that means that you didn't actually calculate it or something. It sort of tips you off to the fact that you did something wrong.
And it's also kind of the worst score, right?
Yeah.
So any score is better than
so the idea is to beat this score, so you keep coming down from this downwards.
Yeah.
Okay.
Yeah, exactly. I mean, because if you think about, if you've got a whole load of different applications of this, right? In some instances, the score might be really high, 50,000 and so on. But in order to encapsulate it for every application, you start off with infinite, then you know that everything else is always going to be better. So that just makes the most sense for it to be a general rule.
I mean, I suppose you could have initialized it as an AND, but I mean, it doesn't matter.
I think, yeah.
Yeah. I'm not sure if I heard him like maybe I heard this wrong, that the leaf score is going to be infinite. Does that make any sense? The score of a leaf is going to be infinite. No, okay. Maybe I in the video somewhere I heard it. That's
you're right. She did say that a number of times. He said that because that's the very end.
Mm-hmm.
He had the diagram and he pointed to the value of the leaf. And he said it starts off as infinite until you, what's the word? I want to say propagate, but that's not the word. When you calculate the values for all of the trees down to the leaf. So that should be, I think, a summation of all of them. But they all start off with infinite. Because remember,
I think it's the same concept, right?
Excuse me?
I'm not sure about the entire code because I can't remember, but I think it's the same concept that basically if you start the calculation, it's inf because it's super bad, and then you improve on it.
Yes.
And same for the leaves.
Okay.
That's why you could use some random numbers. It doesn't matter because you know you're going to override it.
Yeah.
Okay. Okay, so and in here, when you call this, you'll have another function called find where split. So that's
the best split between the two. But remember, he was showing it in the spreadsheet, if I remember right. I only watched it yesterday, so still fresher in my memory.
Yeah, it's coming up further down your code. So it's basically a method of this class, and then it needs to be defined.
So I think, okay, so that's probably, no, that's gone somewhere. This is cut off here.
Right.
So I don't remember what was that in find where. it probably was that left hand side and right hand side where he was doing the standard deviation, and then finding which one is better between the two, and finding the score, I guess.
Yeah.
That was that.
For both X and Y, or only Y?
X is the data. X is the feature data, I think, and Y is the label
data.
Yeah.
Or category data.
Yeah.
Yeah. So Y is not being. You don't split on anything in Y. Y is just the labels. X is the collection of features. So you're splitting on features in X, I guess.
Yeah.
Which features in X to split on?
Correct. Y is probably your target variable.
Yes.
Yeah. Okay, so I'll go to the next, and then I think this is what he was that print function. A couple of things. One is Dunder RPR, representative function or representative.
Yeah, it's basically the default class method that tells Python how to represent an object, right? Normally, if you have an integer, a float, or a string, it's always clear how they are represented, as a number or a decimal number or as a string. But if you define a class or an object, you normally, if you go back, you just get back the memory address of this object. On the previous one, you saw the address. And if you want to see actual content, you have to, like here, no, it was, I think, just the previous one.
This one?
Yeah.
Yeah.
Below M trees 0, that's like the first tree. And if you just print that, you just get the object's memory address.
Yeah.
And if you want to see the actual content of this object, you have to define a wrapper under the wrapper function. And that's what he's doing here. It's basically how to represent.
So Christian, the wrapper function here is to display which object?
It's for the class that it's attached to. So this one is from the decision tree. So that's
you're rewriting the default.
Yeah, basically you're overriding this memory printout because that's useless to you. It's that you want some actual content to be displayed, and if it's in the class decision tree, then the wrapper represents one decision tree, right?
Yeah, but then what it's going to print?
That's up to you. That's up to you. Here, what's returned, it's going to be printed. The return value of a wrapper is printed.
This guy.
Yeah, and this one is composed here. You define how it's done. So it's composed of n and the numbers and val, and basically here the f function. If you don't know that, that's fancy new Python 3.6 string operation. So basically that means that in the curly brackets within the string, variables are filled in place. So it'll put in the self n value, it'll put in the self value into a string, okay? And then he's adding, if it's not the leaf value, he's adding other stuff. He's adding the score, and he's adding the split and the var. And all of that is then the representation of this object instance.
So that's a tree then. So it's either a leaf or a tree. The top is a leaf, and the bottom is a tree.
Yeah.
So very, very simple question. If I didn't want to use this f apostrophe,
yeah,
what would be an equivalent? What would be equivalent of doing that?
Different styles. You can use the old school one with the percentage sign. Like if you want to fill in information into a string, you can use %d for decimals, %f for floats, and %s for strings. And then you append them at the end of a string. And this one is new with Python 3.6 that you can write inside. And there's another one with .format that came with Python 3, but I never really used it. I did the Python 2 percentage thing, and now I'm all for the F strings because they're so cool.
Okay, great. Thank you.
Right. And that's basically it. I mean, the return value, you don't have to print actually. It's the method knows that whatever is returned, it's going to be printed.
Okay, yeah. And I think one of the things he mentioned, this is somewhere in his code, he was saying it's a special property.
Yeah, it's a property.
Decorator where you don't call it as a function.
Yeah, the property takes away the brackets.
Yeah, somewhere I think somewhere in a code he did write like called it and then without as a method.
Yeah, properties are kind of special methods that are translated into an attribute. So basically, normally you would just have a instance variable is leaf, and that could be true or false. But with these properties, you can actually do computations inside. I don't know. It's a bit hard to explain. It's also something reasonably new, but I don't know. It's just, yeah. You can read up on properties. They're like special methods.
Yeah. Interesting. I think what he mentioned was when you define it, you can only have a self in it. You cannot pass the values. And then when you call it, you don't call it as a method.
Exactly, because basically when you take away the brackets, there's no way to put in values, right?
Correct. Yeah. Correct. It's quite interesting. So I wasn't aware of. So thanks for that. I'll try it and then see how it works.
Yeah, I kind of force myself to use them more often because they're really cool. But I haven't used them like years ago.
All right. Okay, so let's move to the next slide. That was the
all right. Find better split. Yeah.
What's this? What he's doing here? But this is the left hand side and the right hand sides thing.
Yeah.
Yeah. So I think I kind of like I made sense of it, like what he's trying to do here.
Mm-hmm.
Anybody else want to have any opinion?
The part that threw me off was how he made it more efficient. I don't really understand that, where it went from 700 milliseconds to 70 milliseconds. That part I didn't get.
Yeah, so that would be, I think that was this guy speeding things up. What I got from that is he mentioned that he's gonna sort his data so that in every loop he doesn't have to go through every single value. Again, I haven't tried it, but this one is probably you're talking about where he sped up things quite a lot. Rewrote this function. So I think initially he wrote this function and then he rewrote this function as this, have a more elaborated.
To be honest, I can't remember. But can you go back to the original one first?
Yeah.
See, normally, if you make things more efficient, you almost always make things smaller. And so here he's made it larger by adding the sorts, and it runs faster. But then there's these duplicates that are in the data, like 1, 1, 2, 2, and if they're dispersed randomly, then you have to read the entire list.
That's okay. You can proceed to the next one again.
So I think one of the point he was making is this, where you have the formula for a standard deviation. Again, I cannot pronounce it. It's like it's this sum of square minus or something like that. I think somebody asked them, and he was quite. This is the zeal of, I think, speeding things up. That's all I knew. And this is something to do with the standard deviation, how he's calculating standard deviation in a previous slide as compared to in this function. Now, I'm not quite sure how it's sped up, but that was one of the points.
If you look at the formula for standard deviation, it's the sum of the residuals with the mean. So it's the sum of xi minus x bar quantity squared, and I think he's just expanding that out, and he's basically made it more efficient. So you only have to calculate the mean. To get this formula, you only have to calculate the mean and the mean squared. But it's just the same thing as the sum of the x minus x bar quantity squared. You just expand it out, and then it becomes this formula. If the mean, let's see, I mean, if you just expand it out in a quadratic, you know, x minus x bar squared, you get x squared minus 2x bar x minus x bar squared. And I think x bar is, let's see, if you take the average of, let's see, okay, so if you take x minus x bar quantity squared, I just expand that out as a quadratic, right? Are you following?
Yeah.
Okay, you get x squared minus 2x x bar minus x bar squared. Okay, but the x's are really, instead of x, it should be xi, where I is one of the data points. So now you're taking the sum over I of all that, and so let me, I don't know, I don't want to hold you guys up, but I mean, if you sum over I of that and you simplify it, you get the formula that he has at the top right there. And it speeds things up because you only have to calculate the mean once and the mean squared. It just makes the formula faster to compute. That's all that is.
Okay.
Mm.
I'll write this up and mail it out. It's just a simple calculation.
But I mean, the like also from the previous slide, the general kind of concept is clear, right? With the left-hand side and right-hand side, and
yeah,
okay,
yeah. So conceptually, it was fine. Yeah,
okay.
yeah. And then especially like you do the left-hand side, the right-hand side, and then you do the comparison, and
Exactly.
whichever is the least, you just store it here. Yeah.
So just a quick one there. Someone said, you know, the score could have been a nan. I'm not sure it could be, because if you're then doing a comparison later, you'd want it to be infinity rather than nan, right?
You're right. You're right. It has to. You're right. It has to be a number. I'm wrong. It has to be a number.
If you could write up, you know, if you could do a write up on that, on why this is happening, that would be great. That'd be really helpful. Thank you.
Yeah, the function std_ag. I'll write up the explanation for that.
Okay, great. Thank you very much.
Yeah.
Thank you. Okay, so the next one is, now I got lost here. So I didn't understand, like I thought I got it, but then here it says find var split. I literally gave up around here. So what is this doing now? I thought we found the score, like, you know, the better split, or like this is where we are getting all the score. So what's this find var split?
I think that's the actual one that we saw where on the original one where it was cut off. That's like the parent one, and that's calling this helper find better split one. Like if you go one back.
Here?
Yeah, on the bottom, you see the find var split. So that's like the kind of main variable split function, and that's calling as a helper function the find better split one, if I recall correctly.
Okay. Okay.
So kind of building up.
So what's the C attribute there then?
Sorry.
Which one? What are you talking about?
Because in the next thing there's the var split, and it refers to something self.c. What is C? What variable is, or what is he holding?
Can you move to where that is? Yeah.
I can't see the variable. Yeah.
Where do you want me to move? Which?
No, can you move? I think you need to move 2 slides down, please.
Here it is.
Is this?
Self C.
Yeah, that's the one. Yeah. Okay. What is that? What is that C there referencing?
I think we have to go back to see where it was defined.
Okay, here I don't see here.
No, it must be on the class. Here, it's the shape dimension 1.
Here?
Yeah.
Oh, okay.
So that's also like super compact assignments, right? The first variable
Okay.
gets len, and the second one gets x shape 1.
Yeah.
So that would be, X shape 1 would be the number of columns, right?
The number of features.
The number of features, yeah.
Yeah.
Okay.
So
Yeah.
basically the number of things it can split on.
Yeah.
Yeah.
And I think the output is going to be the two things. Well, the output of this split thing, is that going to be just two features, or I'm not sure.
I think it's looking for the variable there that gives you a better split. So it's testing all possible features, and it'll give you.
Yes.
It'll give you the best.
Yes, that's right.
I think. So it's, with this loop, you're kind of testing all features.
Finding the best feature to split on.
Yeah.
Okay. And then they get stored here.
So basically, it's building a tree for the left side and the right side, right? It's kind of a recursive thing. So
Yeah.
it walks down and always builds new splits.
Okay. I think we need to put it in a notebook and run it few times to make sense out of it. But it's very helpful explaining the code.
Okay.
All right, so move on.
Sorry, just
Also,
one question.
Maybe we should point out, sorry, the addition, because you also mentioned that the decision tree find bar split equals find bar split, right? That's something really Pythonic, that you can actually dynamically assign a function into a class function, right? So quite often for people coming from other languages, that's totally alien. So you can define a function and then kind of stuck it onto a class dynamically.
Oh, yeah.
So say again. So this is the function, that function.
Right, that's defined here outside of the class, and it's put into the class under the name find bar split. Here it's just a coincidence that they are both the same name, but they are different entities.
Okay, so this function is outside the class. Now
up till now,
and then when he assigned to this variable, it's
now
kind of like it's a method you're sending to a class. So now this function belongs to this class.
Yeah.
Yeah.
And that's
Oh, interesting.
But you need this self attribute in your function, right? On the top, self always references to the class. So to access anything on the class, you need self.
Wait, so you can pass self outside of the class?
It's kind of funky that it's possible to have it outside.
Yeah, I remember he doing something, this creating as a underscore foo, and then saying underscore foo goes to find where split. So you can even have so this variables, you don't need to define a variable in a class itself. So you define a function and assign it to any name within that class, and that function will belong to that class. Yeah,
they don't have to have the same names. I think he was demonstrating that with the foo.
Why, like, what's the, is there any advantage or is it just a flexibility?
You can kind of patch classes or extend classes or modify classes on the go. Like in this case, it's not really necessary. I think it was just demonstrating some language features.
Would you have any function in a class A which you can assign as a class B?
Like one thing where I use that is you can have like a second file, Python file with functions, and have the user decide which one gets assigned to the actual behavior of this class. But to be honest, if I would have written that, I would have written it right in the class, because I don't see the point why it should be outside. Yeah. It's not necessary in this case.
Well, one reason why, I mean, you're right, in this case, maybe not, but in another reason, maybe you're defining a number of classes and you want them to all have access to this function.
That's true.
That would be a good way to do it.
Yeah, if you have universal kind of functions, you can kind of build a toolbox of methods and just add them
like
to
a global function, the idea
true.
of a global function.
Okay, We are running out of time, so I'm going to move on to the next one. So that's the prediction.
So just a quick question. So does this code only work on Fast.ai 0.7? So you've got to actually be on 0.7 rather than 1?
I think this one is totally independent of Fast.ai.
Yeah. So this one is like him writing or individual writing this random forest from scratch, not even using a scikit-learn.
Yeah, you don't need any Fast.ai for that.
Yeah.
All right. Okay.
Yeah. That's just straightforward prediction. And then yeah, so there are two things he mentioned. Python, gist.
Yeah, gist is spelled wrong. It's an I. It's just a GitHub thing that you can upload your code without creating a big repository. You can just do a like code snippet up on GitHub.
I found it actually quite helpful. Like if you get stuck somewhere on an error, you don't find it, you just share it and then show it to other people. So I thought this is very good for beginners like me.
Yeah. And Python is just like a numerically optimized version of writing code. Basically, you insert type definitions, and therefore you can have a C compiler at the bottom optimize your code, because in Python everything is dynamic, and therefore the language can't really optimize the variables and stuff. But in Python you can basically specify that this one should be a float and this one has to be like a 4-character string, stuff like that, and then the underlying code gets optimized and then it's faster. So it's kind of a bit of a highly optimized Python, but it only supports like 90% of the language, so you can't do everything with Python.
And is Python already in the Fast.ai library, or do you have to import it?
I think it's a library that you need to import. I don't know if they probably import it for Fast.ai.
Mm-hmm.
So with a gist, does it go to your repository on the GitHub, or does it go to some sort of?
I think it's linked to your account, but you don't have to actually open a repository in it. It's kind of an ad hoc repository for a single file.
Okay.
Where is the practical use of Python as such?
Performance optimization. Like if you want to increase the speed of a certain function, where you know that like if you have a super optimized code, like if you sometimes like NumPy, like almost everything in NumPy is written in C, in raw C, and then it's patched into Python because it's still faster. And if you have a really purely numerical function and you know that with pure C you could be faster, you can write it in C or in Python, which gives you still pretty much Python-like syntax, so you don't have to write it in C.
So would we say if anything to do with the like online streaming information, some sort of like we want to have a model which should work, for example, nowadays they are saying they're doing image recognition as you enter to some shopping mall, and then they're running a model on your appearance and then what you're gonna do, like are you buying what or not. This
stuff is optimized anyway, like OpenCV, this vision library, that's all C. There's Python, is just a wrapper, and I personally never wrote myself any Python, but a lot of these numerical libraries use it.
And how this would be different, Python would be different than Spark. I think what Scala, which they have written, Spark is written in Scala. So that's for an optimized version of, I think, Java. I
think that it's a type language, right? Can't remember. So anything that has type definitions like C or C++ or Java is faster because the processor can optimize the memory allocation and everything.
Mm-hmm.
And in Python, it doesn't really know what's coming up because they can be anything. You can override stuff. You don't have to type def a variable. You can just say A equals something, right? And it can be a string, a number, anything. And therefore, it has to infer at runtime what's happening, and that makes it slower.
Yeah, I think the takeaway is the fantastic speed up that he accomplished using Python. He showed first using Python with without using type definitions, and he still got a speed up. But then when he used the type definitions, he got a fantastic speed up. I think it was 100 times or something.
Yeah. Like for this pure for these dedicated blocks of purely numerical code, it can be big. But normally, like if you write a program, you have a lot of stuff going on, and then it would be only some functions where it's worth optimizing like that, I guess.
Okay. You're saying that there's some functions that are bottlenecks and you can't really get around them by Python, and so sometimes you might try to optimize the Python, but you don't get as much speed as you think because there were other bottlenecks that were preventing it. Yeah,
but to be honest, I mean, like I said, I never used it yet because, like, if I do numerical stuff, I just do it in NumPy. That's already optimized. So if you rely on NumPy and stuff, that's all pure C under the hoods anyway.
Okay, I didn't realize that. And also PyTorch does the same thing, right? I mean, PyTorch makes use of NumPy.
Yeah. PyTorch is also optimized.
But it adapts it for tensors.
Yeah, I think C or C++.
Yeah.
Also, I've read or heard that NumPy is actually also Fortran in many ways.
Fortran is the same. Yeah, Fortran and C, they're all kind of more closer to the metal and therefore faster.
Yeah, I've heard there was one interview with Jeremy, and then basically he was saying that there was a question, which language should they, because there was a question about from the PyTorch creator, if Python was the right choice of language, and Jeremy was kind of saying that actually they need better language than Python, because everything is like written in C or C++ or Fortran, all the core stuff. So Python is actually like a wrapper. I think I could go there in some way. Yeah, it's a good lesson.
All right, that was pretty much it from. I guess we finished with the random forest this week. Next week, all new stuff.
Thank you. That was a very useful, run through. I think made us all.
Yeah, yeah. Thank you. Just one quick question. So I think you mentioned at the start that, you know, random forest is not great at extrapolating models. So for example, if you don't have the actual range in your data, then random forest can't help you. But neural networks can.
Yeah.
What property of neural networks actually allows you to extrapolate?
Because you learn a function. Random forests just do a nearest neighbor thing. So if you don't have any value in the close by that it has seen before, then there's no way it can replicate it. I think he mentioned something like if the sales are now suddenly 30% higher, and in your entire data set that never happened, then there's no way random forest can replicate that. But with a
So what about neural nets? What about neural networks allows you to extrapolate?
Because basically they are linear functions that are kind of broken up with these activations afterwards. So you can basically learn relationships.
Yeah, I think that the most basic, like a neural net, he says, is like linear regression, which is basically just one function without the non-linearity added. And basically, if you have 2 points, you can draw a line, and then you can, even without seeing the points that goes, you can basically predict what that line is, and then you can predict even on the points you didn't see. It's still a prediction because you still don't know what that would be, but at least give you some sort of direction where that would go.
Yeah, imagine that you had a histogram of bins between 1 and 10. Say you had 10 bins, and in each bin you have a number, right? And so with that function, with that histogram function, you can't predict what happens outside of that interval between 1 and 10, or I guess 0 and 10. But if you had a linear function, you know, y equals ax plus b, then you can predict what happens at any point x. That's what.
Okay, sure. Okay, but so this is where I'm confused, because random forest has two abilities. One is classification, which is what your histogram example is about. But you also have random forest as regression, which is basically what linear lines are. So I get. I mean, I appreciate Christian's point about it being like nearest neighbors, But if random forest is a regression, why can you not make a prediction then? Because it's not only a classification.
Because random forest is like a piecewise function. So you have values assigned in bins. Like if x is less than 0.5 and greater than 0.3, then you can make an assignment. And so it's a piecewise function, and the piecewise function is only defined within the range of your data. So you can't go outside that range. Is that making any sense?
Mm-hmm.
Cool. Okay, that makes sense. Then what is the regression capability of random forest then? Because I think I'm missing the point.
It's able to solve for floating point. It's able to solve for non-discrete. Classifications are discrete, so random forest can be applied to classifications, but it can also be applied to regression problems where you want to predict the value of a function that might have a floating point value.
Within your range.
Yeah, within your range. It's a piecewise model.
Gotcha.
It's like a piecewise model.
Okay. Okay, that makes sense. Thank you.
Just one quick point. I think last week there was a debate. So I wasn't there, so I overheard. I was just traveling. I'm not sure whether this was the slide which the homework. There was some homework to be done. Anybody remember what was we wanted to rediscuss the point from last week?
Don't remember anything.
Okay, I'll leave it here then, because I don't exactly remember what was the debate, and then we said, okay, so we're gonna do some sort of a homework on it. But I'll leave it here. We're over time. Anybody else want to discuss anything? Otherwise, we'll finish.
I just want to highlight real quick. I just glanced at my notes before we started, and I think this was the week he discussed oversampling for when you have a different ratio of points of values in the labels set, such that you might increase the frequency of your less common labels in order to get consistent sampling of labels in the backpropagation. I've actually implemented it in the software tool that I talked about last week as a way of levelizing the frequency of labels in an automated fashion. I have a new paper that's about to be published in Towards Data Science on Medium. You can find me by my name, Nicholas Teague. So, any feedback is always welcome.
Nicholas, you want to do a proper presentation, maybe 10-15 minutes to walk through that, maybe in our next lesson for that?
Yeah. Well, I'm going to be traveling next week for the holidays. I'm not sure if I'll be able to sit in.
Week after, what we are looking is probably the idea is in a deep learning, the guys they go through the lesson and they try to do a mini presentation, and that's what we're looking here as well. Anything they want to add, their work.
Do a quick walkthrough of the demonstration. I've been sharing some collaboratory notebooks demonstrating applications of the tool, so I can probably go through a quick demonstration. I don't have like a packaged product rolled out yet. It's kind of right now still in getting some of the architecture stuff settled, but all this object-oriented stuff in the Fast.ai course has been helpful.
Yeah, I mean, like anything would help, just maybe a couple of slides or just walk through a code or anything you want to add, that more than welcome. And that goes to everybody. If anything they want to present.
And the host, could you tell us your name, because you're labeled as Team TWiML. I don't know your name.
My name is Dinesh.
Dinesh.
Actually, so we all are, like me, Christian, Michael, and Sanyam. There are 4 or 5 people on these slides. I'll show you the first slide. These are the guys which try to take. Okay. Yeah, so. Just put it on a Slack. Just throw in a Slack saying, okay, I want to present, and then one of us will pick it up.
Okay.
Okay, guys. Okay. Have a good evening, afternoon, morning, wherever you are, and I'll see you next week.
See you guys. Bye-bye.
See you next week.
Thank
Thanks. Bye.
Bye-bye.
Bye-bye.